Pick a number, any positive whole number. If it's even, cut it in half. If it's odd, triple it and add 1. Now repeat. Keep going, and something strange happens. No matter what number you start with, you always end up at 1. Always. At least we think so, because this rule, simple enough to explain to a child, has defeated every mathematician who has ever touched it. It is called the Collatz conjecture, and it might be the most dangerous problem in mathematics. Here's the whole game. Take a number. Even? Divide by 2. Odd? Multiply by 3 and add 1. Start with 6. 6 is even, so it becomes 3. 3 is odd. 3 times 3 plus 1 is 10. 10 becomes 5. 5 becomes 16. And 16 is a power of 2, so it collapses. 8, 4, 2, 1. Done. Every number we have ever tried funnels down into that same final loop. 4, 2, 1, forever. But the path down is anything but smooth. These sequences are called hailstone numbers, because like hailstones in a storm cloud, they rise and fall over and over before finally crashing to the ground. Start with 7, and you climb all the way up to 52 before falling. Start with 27, an innocent little number, and something wild happens. The sequence takes off. It climbs over 9,000, dropping and spiking, refusing to settle, for 111 steps before it finally lands on 1. And here's what makes it so maddening. Neighboring numbers behave nothing alike. 26 needs just 10 steps. 27 needs 111. 28, 18. There is no visible pattern, no formula that tells you how long a number will take. The rule is completely deterministic, no randomness anywhere, yet the behavior looks like pure chaos. It's as if each number rolls its own dice, except there are no dice. There is another way to see it. Instead of following numbers down, run the rule backwards and let every number grow out of 1. What you get is an enormous branching tree, with every whole number hanging somewhere in its canopy, all connected, all draining into the same root. The conjecture simply says, every number is on this tree. No separate island, no runaway branch that shoots off to infinity, no secret loop hiding among numbers too big for us to check. And yet no one can prove it. Computers have checked every starting number up to nearly 300 quintillion. Every single one falls to 1. But checking is not proving. One exception, anywhere in the infinite line of numbers, would bring it all down. The great mathematician Paul Erdős looked at this problem and said, mathematics is simply not ready for such questions. He offered $500 for a solution. The money has never been claimed. A rule a child can follow, hiding a question no genius can answer. That's the strange beauty of mathematics. The border of the unknown is not far away in some abstract wilderness. It's right there, 3 times n plus 1, waiting. This has been actually rendered. If you enjoyed the ride, you know which button to press.